think it's the 8th. Okay. First, we should talk about transformations. First of all, before I even explain what they mean, we have to go through a list of basic functions. List of basic functions. Transformations mean nothing if I don't know how to graph the simplest function from several categories. So if I don't know, number one, linear, the simplest possible linear function is f of x equals x. If I don't remember that this graphs like this, I'm going to use a different color for the graphs. If I don't remember that this is the graph of f of x equals x, then transformations, which we don't know what they mean yet, on this function will mean nothing. Can anyone tell me whether this function is odd, even, or none of the above? Odd, even, or none of the above? Okay, the function is odd. It's symmetric with respect to the origin. Number 2. Simplest linear, simplest quadratic. If I don't know that the simplest quadratic function is x squared, and if I don't know how to graph it, transformations on this function will mean nothing. I will not be able to identify them. I will not understand what needs to be done. So this is the graph of f of x, which is x squared. Is it odd, even, or none of the above? Anyone?
Even.
Thank you very much. Even, being symmetric with respect to the y-axis. Great job. Number 3. Absolute value. If I don't know that the simplest possible absolute value function is this, and I do not have embedded in my system the graph of this function, then transformations on it mean nothing. I won't be able to identify them. So this is what is called a V function. Okay, odd, even, or none of the above?
Even.
Thank you very much. It is even. Good. If I don't remember the simple square root. The simplest possible square root is this. If I don't remember its graph, which is this, transformations with this function, I'm not going to be able to understand them. Odd, even, or not symmetric?
Not symmetric.
Thank you very much. Indeed, not symmetric. Good. Next function. There are a few functions that we need to remember. So another one is number 5, the cube root. Cubic function. X cubed first, and then the cube root. So the simplest possible cubic function is f of x equals x cubed. We used it before, and we used it to identify a particular type of symmetry. Once I recall the graph for you, we're going to use it in chapter 3 a lot again. So this is f of x equals x cubed, odd, even, or none of the above. Very good, awesome, thank you very much. Good. Finally, the cube root. We like this function. The simplest one is this. No transformations, just plain simple cube root. We like this one. It doesn't have restrictions. I can plug in anything. So this is f of x equals the cube root. Odd, even, or not symmetric. Very good, thank you. I'm going to add one more function, which is so far the most difficult one to deal with, which is rational. Because it's very different. But the simplest possible rational function is 1 over x. That's the simplest possible. The basic one. Here's the graph. We haven't really talked about it. We will extensively both these functions in chapter 3. So here it is. This is the graph of f of x equals 1 over x. As you see, it has a line here. We're going to talk about this line where the function is not defined. And it also has a line here where the function does not have a value. Good, odd, even, or none of the above. You can say your graph is not looking good, and I would have to say, yes, it's not really, doesn't really look symmetric, but it is. So my apologies, my graph is not perfect. Far from. Okay, now having in mind these graphs, linear, quadratic, absolute value, square root, cubic, cube root, and rational, we have to have a picture in our head. So when we say quadratic, we have to see this. When we say absolute value, you have to see this. Already picture these in your head. Now we can talk about transformations. What is a transformation? Okay, we have several categories. And we are going to talk about all of them. On basic functions, the ones that we just listed. And here's what we have. 3 major categories. Shifts of 2 categories, horizontal, vertical, reflections, second category, with respect to WRT, with respect to the y-axis or origin. And the last one, stretching or shrinking. Stretch, shrink. Horizontal, one category, vertical, a different category. So basically 1, 2, 3, 4, 5, 6. 2 possible shifts, 2 possible reflections, and 2 possible stretching, shrinking of the graph. We're going to start slowly, we're going to build together, and then we're going to make combos. Okay, so we're going to start with shifts. Let's suppose I want to graph a function that is f of x equals x squared minus 3. Later on, when I'm done, I want to graph this function that is x squared plus 4. I'm going to ask you, step number 1, what is the basic function that I used to create f and g? I used one particular base function from the 7 that we looked at.
Quadratic.
Excellent. So the basic function is identified to be x squared. Good. Now I compare to see what is the second step. I compare x squared to x squared. They are the same. This one, if you want, really means plus 0 or minus 0. We don't need to write that, but that's exactly what it means. But this one has minus 3. It does not change x squared. There is no change in x squared. It's just that it has an attachment of minus 3. My first question here is, do I change, or does the function change x or y? This is my immediate question in my head. Because if it's a change in x, then the transformation, the shift, will be horizontal. If I identify that it is a change in y, then the shift is vertical. Since x was not changed, just the final answer was changed by adding this negative 3 here. This particular one is a transformation on y. And obviously, if from all heights, all x squared, I subtract 3, the graph shifts down 3. So this is down 3 units. So when I graph the base function, I will always graph the base function. Here it is. This is x squared. But now I have to shift this graph 3 units down. 1, 2, 3, right here. And this is the graph. Same shape, everything the same, just a shift. This is x squared minus 3. Because it was a transformation on y. X squared is not changing anyway. Obviously, the second one will be a shift that is up 4 units. So then when I graph G, I go 1, 2, 3, 4, right here. So this is the graph of x squared plus 4. Now, you can immediately do this in your head. And if I ask you, without even looking at the graph, what is the range of that function, you will say 4 to infinity. In a snap, right? Of a finger, right? So the range for this function is 4 to infinity. You can already picture this in your head. Once you know x squared, now you know that x squared minus 3 must have a range of negative 3 to infinity. Just like that. Because you know transformations. Not all of them yet. You know what it's called a vertical shift. So this was a vertical shift. Either up or down. Because it's a transformation on y. Okay. Next step, let's take a look at f of x equals the square root of x minus 4. And let's look at g of x with the square root of x plus 3. I'm going to ask you, what is the basic function? I will always ask you, what is the basic function? So we know which of those 7 functions we are working on. One particular one. So what is the basic?
The square root.
Very good. It is the square root. Now I have to compare my second question to myself. Change x or y. It cannot be both. Do I change x or y? I don't know. I'm going to compare. Square root, yes. Anything attached to it? No, I don't see anything attached to it. But this one has x, and this one has x minus 4. So now from x, I subtract 4. Also compare these two, and I see, is there anything attached? No, there is no attachment, which means there is no transformation in y. It must be a transformation in x, because initially this had x, and now I replaced x by x plus 3. So every time we replace or change x, it must be a horizontal shift. So it's not this, but this. We are changing x. Also, this is not a big secret to us, because we know that the domain of this function has to be x minus 4 greater than or equal to 0. We discussed that. This piece, whatever it's under the square root, has to be greater than or equal to 0, which makes the domain 4 to infinity. So I know exactly where this function is going. Do not get confused. It's not going to the left. It's going to the right. Also this one, I have to write x plus 3 greater than or equal to 0, which makes x greater or equal to negative 3. Don't get confused. It's not going to the right. It's going to the left. 3 units. So let's graph the base function. The base function is the square root of x. Here it is. X minus 4 clearly states move to the right. So 1, 2, 3, 4, same shape, everything the same. This is the square root of x minus 4. This is a right shift. Of course, of 4 units to the right. The other one, x plus 3, is a shift to the left of 3. 1, 2, 3, right here, at negative 3. So this is the square root of x plus 3. So we always identify what changes first, and then we conclude where the graph is going. So this was a horizontal shift. When we change x, we're talking about horizontal shifts, like this situation. Okay, I'm going to create a combo now. So let's say we have f of x, which is the absolute value of x plus 4 minus 3. And you can say, how do I start this? How do I think about it? Very simple. First, like before, we have to identify the basic function I used. If I use more than one basic function, then transformations are out the window. So I only used one function. So which function did I use? Absolutely. Very good. Now, this is a very important note. Transformations must be applied, if you want presented, only in the order of operations. Only in the order of operations. As if I'm evaluating. If you ask me evaluate this for 0, I will first perform 0 plus 4. That's my first step. Then I apply the absolute value. And then the final step is I subtract 3. Same thing here. So the first step is the base function. Got it. Second step must be x plus 4. What type of transformation is this? Is it a horizontal shift or a vertical shift? Inside the absolute value, inside this operator we call it, instead of x, I have x plus 4. And inside the absolute value, there is nothing outside. So is it a transformation on x or a transformation on y? On x indeed. And it must be a left shift of 4, of course, units. Finally, the last step must be with negative 3. But notice that this was a transformation on 1. What I'm going to write next, which is x plus 4 minus 3, is a transformation on 2. And now I compare. What is my prop? This is the same. This is the same with this, but now outside minus 3. What transformation is this? Is it a transformation on x or a transformation on y?
Y.
Very good. So this is down 3. Good. So now this was a combo. It had two transformations. First it has a left shift and another step, a down 3. Okay, so let's graph it. So I'm going to graph first the absolute value of x. Here it is. Right in the middle. Then you told me to shift it 4 to the left. Fine. So this is the absolute value of x plus 4. And now you told me shift it down 3. Fine. I will. This is the final function. You don't have to do that. I just want to make sure that it's clear which one is the final function. The absolute value of x plus 4 minus 3. Can you give me the range of this function? I know you know the domain is all real numbers. But can anyone give us the range of this function?
-3 to infinity.
Great job. Thank you very much.